The maximum amperage for each tenant space meter in a meter center or stacks is not a fixed value like 200 amps or 400 amps. It is determined by several factors related to the specific electrical design and the requirements of the building and its tenants. Firstly, consider the size and type of electrical equipment used within the tenant space. A large retail store with heavy machinery will naturally have a higher electrical demand than a small office. The amperage rating of the tenant's main breaker and subpanels must be sufficient to handle the anticipated load. Secondly, the electrical demand of the tenant's business plays a significant role. This involves calculating the total power consumption of all equipment, lighting, and other electrical devices. Demand factors, which account for the fact that not all equipment will be operating at full capacity simultaneously, are also considered. Thirdly, the capacity of the electrical distribution system serving the building is a critical limitation. The main service entrance, transformers, and distribution panels must be sized to accommodate the total electrical load of all tenants, plus any common area loads. The available fault current at the meter location also needs to be considered for proper overcurrent protection coordination. Several codes and standards govern electrical installations and influence the determination of maximum amperage. The National Electrical Code, or NEC, is the most widely adopted code in the United States. It provides detailed requirements for conductor sizing, overcurrent protection, grounding, and other aspects of electrical safety. Local building codes may also impose additional requirements. Engineering calculations are essential for determining the appropriate amperage rating for tenant meters. These calculations involve summing the connected loads, applying demand factors, and considering voltage drop. The calculations must comply with the NEC and other applicable codes. Coordination studies are also necessary to ensure that overcurrent protective devices, such as circuit breakers and fuses, are properly coordinated to minimize nuisance tripping and maximize system reliability. Furthermore, it is essential to consider future expansion when determining the maximum amperage for tenant meters. The electrical system should be designed to accommodate potential increases in electrical demand as the tenant's business grows. This may involve oversizing conductors and equipment or providing spare capacity in the distribution system. Meter centers typically house multiple tenant meters in a centralized location. The design of the meter center must comply with the NEC and other applicable codes. The meter center must be properly grounded and bonded to ensure electrical safety. Each tenant meter must be clearly labeled and identified. The meter center must be accessible for maintenance and meter reading. The electrical utility company also plays a role in determining the maximum amperage for tenant meters. The utility company is responsible for providing electrical service to the building and ensuring that the electrical system meets its requirements. The utility company may have specific requirements for meter sizing, metering equipment, and service connections. A load calculation is a fundamental step in determining the appropriate amperage for tenant meters. It involves calculating the total electrical load of the tenant space, including lighting, receptacles, equipment, and appliances. The load calculation should be performed in accordance with the NEC and other applicable codes. Demand factors are applied to the connected loads to account for the fact that not all equipment will be operating at full capacity simultaneously. The NEC provides tables of demand factors for various types of occupancies. The calculated load is then used to determine the required amperage for the tenant meter. Voltage drop is another important consideration when determining the amperage rating. Voltage drop occurs when electricity flows through a conductor, causing a reduction in voltage at the load end. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC limits the amount of voltage drop that is permitted in electrical circuits. The length and size of the conductors must be selected to minimize voltage drop. Overcurrent protection is essential for protecting electrical circuits and equipment from damage due to overloads and short circuits. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the required overcurrent protection for various types of circuits and equipment. The overcurrent protection must be properly coordinated to ensure that it operates correctly and does not cause nuisance tripping. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protective device to trip and to energize the circuit. The NEC specifies the requirements for grounding electrical systems. All metal enclosures and equipment must be properly grounded. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to minimize the risk of electric shock. The NEC specifies the requirements for bonding electrical systems. Electrical inspections are essential for ensuring that electrical installations comply with the NEC and other applicable codes. Electrical inspectors review the electrical plans and inspect the electrical work to verify that it is installed correctly. Electrical inspections help to identify and correct potential safety hazards. It is important to consult with a qualified electrical engineer or contractor to determine the appropriate amperage rating for Tenant meters. An electrical engineer can perform the necessary calculations and ensure that the electrical system complies with all applicable codes and standards. A qualified electrical contractor can install the electrical system correctly and safely. Furthermore, the type of business the tenant operates significantly influences the amperage needed. A restaurant, for example, will likely require a higher amperage than a small accounting office due to cooking equipment, refrigeration, and other high-power appliances. Data centers or server rooms, even within a tenant space, demand considerable amperage to power servers and cooling systems. Retail spaces often have variable amperage needs depending on the type of merchandise and display lighting used. Industrial tenants can have very high amperage requirements based on machinery, manufacturing equipment, and specialized processes. Understanding the nature of the tenant's operations is critical for accurately estimating amperage requirements. Also, the building's electrical infrastructure dictates the limits of available power. The size of the main service entrance, the transformer capacity, and the distribution panel ratings all contribute to the overall capacity. If the building has a limited electrical capacity, it may not be possible to provide each tenant with a very high amperage service. Upgrading the building's electrical infrastructure can be expensive and disruptive, so it is important to consider this limitation. The voltage of the electrical service also plays a role. Commercial buildings typically have either 208/120 volts or 480/277 volt systems. The amperage requirements will vary depending on the voltage. For the same amount of power, a 480-volt system will require less amperage than a 208-volt system. The specific type of electrical meter used can also affect the maximum amperage. Some meters have a higher amperage rating than others. The meter must be sized appropriately for the anticipated load. Smart meters, which provide real-time energy data, are becoming increasingly common. These meters can help tenants monitor their energy consumption and identify opportunities to save energy. Coordination with other building systems is important. The electrical system should be coordinated with other building systems, such as the HVAC system and the fire alarm system. This helps to ensure that the systems operate safely and efficiently. Energy efficiency is an increasingly important consideration. Tenants are often interested in reducing their energy consumption to save money and reduce their environmental impact. The electrical system should be designed to be energy efficient. This can be achieved through the use of energy-efficient lighting, equipment, and controls. Consider the impact of future technology. As new technologies emerge, tenants' electrical needs may change. The electrical system should be designed to be flexible enough to accommodate future changes. This may involve providing spare capacity in the distribution system or using modular equipment that can be easily upgraded. And remember that safety is paramount. All electrical work must be performed by qualified professionals in accordance with all applicable codes and standards. Electrical safety should be a top priority. The amperage calculation needs to adhere to the guidelines in the National Electrical Code, or NEC. Article 220 covers branch circuit, feeder, and service calculations. These calculations determine the minimum size of conductors and the rating of overcurrent protection devices. Different occupancy types have different calculation methods and demand factors. The NEC provides specific guidelines for calculating the load of lighting, receptacles, appliances, and equipment. The demand factors are based on the statistical probability of equipment operating simultaneously. The NEC also addresses the calculation of motor loads, which can be significant in some tenant spaces. The calculations must take into account the motor's full load current, starting current, and duty cycle. Also consider that the available fault current at the meter location is crucial for selecting appropriate overcurrent protection devices. Fault current is the amount of current that would flow during a short circuit. The overcurrent protection devices must be able to interrupt the fault current safely. The fault current calculation is based on the impedance of the electrical system. The impedance includes the utility transformer, conductors, and other equipment. The fault current can vary depending on the location within the building. Furthermore, tenant lease agreements often specify the amount of electrical capacity that is provided to the tenant. The lease agreement may also address the cost of electricity and any limitations on electrical usage. It is important to review the lease agreement carefully to understand the tenant's rights and responsibilities. The building owner or manager is responsible for maintaining the electrical system and ensuring that it is safe and reliable. The building owner or manager may also be responsible for billing tenants for their electricity usage. The electrical system should be inspected and maintained regularly to prevent problems. Regular maintenance can help to extend the life of the electrical system and improve its performance. Also consider accessibility requirements. The meter center must be accessible to authorized personnel for maintenance and meter reading. The meter center should be located in a well-lit and secure area. The meter center should be designed to protect the equipment from the elements. Tenant improvements or alterations can significantly impact electrical demand. Before any tenant improvements are made, a thorough electrical review should be conducted. This review should assess the impact of the improvements on the electrical system and ensure that it can handle the increased load. Permits may be required for electrical work. Coordinate with local utilities. The local utility company should be consulted when planning electrical upgrades or new installations. The utility company can provide information on available capacity and connection requirements. Utility companies may have specific requirements for metering equipment and service connections. Finally, make sure you document all calculations, plans, and specifications related to the electrical system. This documentation can be helpful for future maintenance, upgrades, and troubleshooting. Proper documentation can also help to ensure compliance with codes and standards. Remember that determining the maximum amperage for tenant space meters is a complex process that requires careful consideration of many factors. It is important to consult with qualified professionals and follow all applicable codes and standards to ensure safety and reliability.